So here we are at section 5.5, which is properties of logarithms. And we're going to look at a lot of different properties that logarithms have that are very similar to properties that exponents have. And I'm going to kind of point out those similarities as we go along. But this first example here, it says log base A of 1. Doesn't matter what our base is. If I'm finding the log of 1, our answer is 0. And if I just do my exponential sentence, that probably would make a little bit more sense. So if I take A and raise it to the 0 power, I get 1. Okay? And similarly, if I have log of some base of that number, so the base and the number I'm finding the log of are the same, that's going to equal 1. And here, that would mean our exponential sentence would be a to the first equals a. I think it makes a little bit more sense looking at it this way. All right, next we have some properties. And this basically just says if I have some base and in my exponents I have a log of that base, my answer is going to be whatever this is here that I'm finding the log of in that exponent. And it's basically because an exponent and a log with that same base as that exponent will cancel out. All right, and we're left with that number. So in this first example down here, I have 2 to the power of log base 2 of pi, and this 2 and the log 2 are going to cancel out, and I'm left with pi. Okay, same here. Log base 2 of 0.2 to the negative square root of 2, the log base 2 of 0.2 is going to cancel, and I'm left with negative square root of 2. In this next example down here, this next property, if my log base in the sentence, my base is the same as the number, these are going to cancel out, and I have left whatever that exponent is. All right, so here, this is really log base e, that's what the natural log is, of e to the kt power. So log base e of e cancels out, and I'm left with k times t. This last example in part D, it's going to be a little bit of work because we're going to think of how we get the sum of two things in an exponent. This happens when I have the base, the same base that I'm multiplying. I add the exponents. So this would be 5 to the log base 5 of 6 times 5 to the log base 5 of 7. So 5 to the log base 5 is going to cancel, and I'm left with 6. 5 to the log base 5 will cancel again, and I'm left with 7. So this gives me 42. All right, so here we have some other properties of logarithms, and this deals basically with multiplication or division with logarithms. And if we think about our properties of exponents, and I'm going to actually write over here, exponent properties. And if I think about exponent properties where I have the same base, and that's what this is indicating here, like a to the second times a to the fifth, the rule is I'm going to add my exponents together because I have the same base. So this is a to the 2 plus 5 power. Now, when I'm working with logarithms and I have a product inside here, I can separate them by using addition. Okay, so here I had them separated and I put them together using addition. The inverse with logarithms is I'm going to take them apart using addition. Here's the quotient property of logarithms. If I have the logarithm of a quotient, I'm going to take them apart by using subtraction. And the rule with exponents, let's say I have x to the 7th over x to the 2nd power. That would be x to the 7 minus 2, which would be x to the 5th power. So I use subtraction here when I am dividing with the same base. And here I have the base and I'm dividing, so I can pull them apart using subtraction. And down at the bottom I have a log base a of m to some power. And the rule is, this is the product of the power. I'm going to take this r and I'm going to move it to the beginning and multiply. Now the exponent property would be a power to a power. So let's say I have 2 to the x power, and this is multiplied, or this is raised to the 5th power. So I would multiply my exponents together. Okay, so multiplication is the key thing here. And in this case, when I have logs, I'm going to bring this out in front and multiply. So let's use a few of those properties here. And in this first example, it's asking us to write this problem right here. Probably need a, close the parentheses, as a sum of logs. Now it says sum of logs because I'm actually multiplying x by the square root of x squared plus 1. So I'm going to split this up, and because this is a product, I'm going to multiply, and I'm going to make that 2 parts, log base x plus log, and instead of writing the square root of x squared plus 1, I'm going to write this as x squared plus 1 to the 1/2 power, because we're going to think of our square root as an exponent here. Now we also have a property that says if I have an exponent inside my log, I'm going to take this and multiply it in front. So this is log base, or log x, and actually this is base 10 because there's no indication of anything else. And then this would be 1/2 log x squared plus 1. Now, when I have the log and there's a sum inside, notice how I am adding these together, you can't break apart. Okay, so if it's addition or subtraction, you cannot break those apart and have two more logarithms. So we've got to keep them as a group there. We can only break apart if we're multiplying or dividing. In part B, I have the natural log of x squared over x minus 1 to the 3rd power. And it says to write this as a difference of logs. Well, it's a difference of logs because I have division. Okay, so if I'm dividing with exponents, I subtract, and that's where we get the difference from. So I'm going to break this apart. I have ln x squared minus, for the division, ln of x minus 1, and I think that's to the 3rd power. All right, so we'll take care of our exponents as well. We'll move that out in front. So I have 2 ln of x minus 3 ln of x minus 1. Part C asks us to write this logarithm as a sum and difference. So that means I'm multiplying somewhere in here and I'm dividing. All right, so here I have the log of whatever's on top minus the log of what's ever on bottom. So I'm going to write that way. Log, and again, x squared plus 1, I'm going to write to the 1/2 power. And then I'm subtracting log x squared times x plus 1. And that looks like it's to the 4th power. All right, so I'm subtracting all of this. All right, so taking care of the 1/2 log x squared plus 1. And now I'm going to subtract the sum of these two pieces, because I've got a x squared multiplied together and an x plus 1 multiplied together. So I'm going to break those up and have a plus there. So I have log of x squared plus log of x plus 1 to the 4th power. All right, so cleaning this up here, this first part was good. Now remember, I can't break away if it is part of a sum. So I'm going to subtract log x squared, which is, if I bring the 2 in front, 2 log x. And I'm also going to subtract this part. So I'm going to subtract, and I'm going to bring the 4 in front, 4 times log x plus 1. Okay, so this one actually has 3 terms here. In part D, I'm writing this natural log as a sum and difference. So again, I'm going to break it apart. First, I'm going to separate by the subtraction and by the division. So I have ln x squared y to the 3rd minus ln z to the 4th. But this is a product, so I can break this down into the sum of each of the pieces. So this is ln x squared plus ln y to the 3rd minus ln z to the 4th. And lastly, I want to get those exponents out of there, so I'm going to bring them out in front. This is 2 ln x plus 3 ln y minus 4 ln z. In this next part, we're going to go the opposite way. We are going to take multiple terms and write them as a single log. So that means we want to write the word log just one time. All right, so noticing that I have a plus in between these terms, that tells me that I'm going to multiply those numbers together. But before I do that, notice I have this 4 here. That becomes the exponent to this 3. So this is log 7 plus log 3 to the 4th power. So now I have 2 logs. They're both base 10. So I'm going to multiply these numbers together. Write it as a single logarithm. I have a 7 here, and I'm multiplying by 3 to the 4th. Now I can leave it like this, or I can simplify it. I know that 3 to the 4th is 81, and 7 times 81, this is the same thing as log 567, right there. All right, next part. This 2/3 is an exponent for 8, so I have the natural log of 8 to the 2/3 power minus the natural log of, and inside here I can actually do this multiplication. 3 to the 4th is 81, minus 8 is 73. Okay, so if we think of 8 to the 2/3 power, this means I have, I'm going to write this over here, 8 squared is 64, and now I want to take the cubed root of 64, which is 4. So 8 to the 2/3 power is the same thing as ln of 4. And because I have subtraction here, I'm going to divide by 73. So I have the natural log of 4 divided by 73. All right, lots of terms here in part C. I have a plus, and a minus. So I know with the pluses, I'm going to multiply these numbers together, and the minus means I'm going to divide by this number. Okay, these are all log base 10. Okay, so I have log. So I have x times 9 times x squared plus 1. So I'll write that 9x times x squared plus 1. And because I'm subtracting here, I'm going to divide all this by 5. Part D, I'm going to take the 3, make it an exponent for the u. Okay, I notice I have a plus here, so I'm going to multiply, and I'm going to also make that 4 an exponent for the v. So both of these are log base 2. So I'm going to write my log base 2 one time as a single log, and I'm going to have u to the 3rd power times v to the 4th power. And one more time, here this 2 is going to go as an exponent to x plus 1. I have a subtraction and a subtraction. Now I can work this a couple ways. I can factor out the negative term here. So I'm going to have log x plus 1 squared minus log of x plus 3 plus, because I factored that negative out, log of x minus 1. All right, so this tells me I'm going to divide by all of this. So these terms here are going to be on my denominator. So in my single log, I'm going to have an x plus 1 squared, and I'm going to have on my denominator, because I'm dividing or I'm subtracting all of this, so all of this is part of the denominator here. I have an x plus 3 and an x minus 1. All right, so one more part here, one more formula. And here we have what's called the change of base formula. And this is used primarily when we're trying to calculate a log. And in the olden days, before we had the technology that we had right now, if I wanted to find the value of, let's say, log base 2 of 7. Now, on a scientific calculator, I could not put this in this way because the calculators were working in base 10. So there needed to be a formula that I could use to evaluate of logs that are different than base 10 or base e, which was the natural log. So this means I could change to any base, but this is actually working in base 10. So what this means, if I have a different base other than 10 of some number, I'm going to do the log of that number, and this would be log in base 10 divided by log in base 10 of the original base. So I would write this, 7 would be, in this case, the m. I would have log 7 over log of the base, which is 2. And I would just divide log 7 divided by log 2, and that would give me the value of this. So if I look at my calculator, I'm going to bring in one here, kind of zoom in a little bit. To do this problem, I would just use the log and plug in base 7, and I can do this on Desmos. Log base 7 divided by log base 2 would give me a value of 2.807. Is that what I have? Yeah, 2.807. All right, so I'm going to write that here. All right, so the next one tells us we have log base 5 of 89. So I do log of 89 divided by log of 5. And in those calculations, log of 89 divided by log of 5. 2.789. Usually we round to 3 decimal points, 0.789. So we round to the thousandths place when we're working with logs. All right, now this would be the same as, and you can probably find this, I'm pretty sure, on Desmos as well, but on the TI-84 calculator, if you have one, if I use the math key, which is right here, there's a menu to work with, and if I go all the way down, the very last part here in my menu, it's A, it says log base, and then it starts with a parenthesis. If I choose that, it will give me the option to identify what my base is and what the number is I want to find that log of. So if I put in log base 5 and then arrow over and put in 89, I get exactly the same thing. All right, so I'm not particular as to which method you use. You do need to know that if I need to change the base, it's log of the number divided by log of the base. And it's the base that goes on bottom. Okay, so log base, the base number is on bottom. And I remember that with the B's. And this last one here is to approximate log base square root of 2 of square root of 5. So I do log square root of 2 over, log square root of 5 over log square root of 2. And that in my calculator would give me 2.322. All right, so that's how you change or evaluate logs that don't have a base 10 on our calculator. So here is just a summary of the properties that we went over, just kind of all in one place. We have the definition of an exponent, or definition of a log based on an exponential sentence. Okay, this is just the property a to the 0 power is 1, a to the 1 is a. We have our properties with multiplication and property with division, change of base. All right, so you will need to know these and how to use them. And we're going to do lots of practice with this coming up here.